Hello all. I'll be covering today the OSI model. So OSI stands for Open System Interconnect. So they actually International Standard Organization ISO was established way back in 1947. They proposed a model called OSI model for the computer network architecture in 1970s. So this model was created even before the TCP/IP, which we currently use in the internet. But this model was not practically implemented anywhere, basically because the layers were poorly defined. Some layers had no much service to do. So they came up with a better model, that is the TCP/IP, which you have already seen in the previous video, which has five layers. But the basic foundation for the network architecture is in the OSI. So let's quickly go through what is OSI model. So it has 7 layers. From the top to bottom, if you go application layer, presentation layer, session layer, transport, network, data link layer, and physical layer. So application layer is retained same as is retained again in the TCP/IP. So are transport, network, data link, and physical. Only presentation and session layer, which had very little to perform, their activities were merged in the other layers. So it's very easy to remember that this is the sentence. You can remember all people seem to need data processing. So from this, A stands for application, P stands for presentation, S stands for session, T stands for transport, N stands for need, N stands for network layer, D for data link, P for physical layer. So this is the OSI model interaction between the layers. So say device A has to send data to device B, then it has to using some application layer protocol, um, the device A would like to send the data. So from application layer, the data will travel to presentation layer, where the security issues are taken care, encryption, decryption is done, and then it's given to session layer. This is a layer 5. Session layer helps to establish sessions. Sessions are the durations in which sender and receiver can interact. The data is further sent to transport layer. Transport layer, as I have discussed in the TCP/IP, is a true end-to-layer and true end-to-end layer even in OSI, because whenever an transaction has to take place, the port will open in the sending transport layer, another port will open in the receiving transport layer, and the data will move from sending port to receiving port. From transport layer, either the TCP or the UDP service will be carried out, and data will be sent to network layer. The role of the network layer is to find the shortest possible path from source to destination. Then it is sent to data link layer, where frames are created, some flow control is introduced, and the media access layer helps to resolve the conflict of multiple channels sharing the same media. And then the data is given to physical layer. Physical layer sends the raw bits. Now you can see that device A and device B are not in the same network, and they are situated in different networks. So the data has to go from physical layer of one device to the intermediate network, and again go through multiple intermediate networks, bottom 3 layers, and finally it reaches the destination where it will visit the 4th layer. And peer-to-peer communication was also discussed in the OSI model only, where the information as seen by the application layer of the sender is understood only by the receiver application layer. Nobody else will understand it. And you have the bottom layer performing some service to the upper layer. Every bottom layer will perform some service to the upper layer, and application layer will be giving service to the user. So this is the model that was initially proposed. So you can see there is something called data encapsulation and decapsulation happening. What does it mean is, The user sitting on this system wants to send an email. An email is prepared, which is D7. Let us say the data 7 is the email body, to which header is added. Header would be the source destination address. Now the complete thing will be sent to the layer below, presentation layer. Presentation layer will not change that original data. It will add its own header, some encryption key or something. And then it will send it to the data session layer. Session layer will add its own header and then send to network layer. Network layer will take the complete data, add source and destination IP address, sorry, transport layer. Fourth layer is the transport, D4. Transport layer adds the segment number and port addresses and then give it to the network layer. Network layer will be adding the IP addresses and then pass on the data to the data link layer. Data link layer will add a header and a tailor and then give it to physical layer. Physical layer will again add its own header. Finally, the data travels on the transmission media and it reaches the destination. Now at destination, the header information attached by the sending physical layer is understood by the receiving physical layer. And it will remove that header, detach that header and send only the data part to the above layer. Data link layer will interpret the header and the trailer which may have CRC informations and check whether the data is corrupted or correct and also remove header and trailer and give the original data to network layer. On the other hand, network layer will once it reaches a particular destination, no longer the same IP addresses are required. So all that will be removed as a part of the header and original information as received by its layer above will be sent to transport layer. Transport layer also strips off the header, gives the remaining to session. Session layer strips off its header, its counterparts header that was sent by the sending session layer and then gives it to the presentation layer. Presentation will remove the header and give it to the application layer. Finally, the data alone will be delivered to the destination. So what is happening at the sending end is called data encapsulation. Means you are putting data one in the other. Okay. So when we write a letter, we put it in an envelope, put it in the nearest post box. Postman picks all the letter in his bags and gives and then prepares a bigger cover to the central post office. He has not read your cover, correct? Only he has put a bigger cover and attached some address. Then it is sent to the central post office where further a classification of uh, letters to different destinations, different cities. New bags are prepared or new covers are prepared. All the letters to a particular city are put in one cover and a new address is added. So all the way in the sending side, encapsulation is happening. At the receiving side, just remove the cover, take the inside information. Decapsulation happens. So these are the 7 layers of the OSI. Let us go through briefly each layer's functions. Physical layer mainly deals with raw bits or individual bits. So it's the lowest layer in both OSI as well as TCP IP. And the communication between two devices at the physical layer is logical communication because no two physical layers speak to each other. If they are far apart. So what does physical layer basically do is it will decide what should be the voltage levels of zeros and ones. Okay, what should be the encoding scheme. All those it will decide. It carries electrical or optical signals depending on the communication media. So this is the role of a data physical layer. So it's responsible for moving the data from one hop to the next. Then comes the data link layer. So data link layer helps you to route the data between two links. Means you may be having a LAN and a WAN connected together. Okay. So there may be overlapping sets of links that a datagram can travel. So that is taken care by the data link layer. The other jobs of the data link layer are it prepares frames. Okay. So there is one particular frame called HDLC frame. So HDLC frame has two categories. One is bit type, another is character type. In bit type, a particular flag pattern is put at the beginning and the end just to tell where a frame starts and where frame ends. And that particular pattern is 0610 and ends with 0610. And similarly, by the character type of frame, you have a DLE STX at the beginning, stands for data link escape start of text, and ends with data link escape end of text. So initially there was a flow control done in the data link layer alone. But now it's mostly taken care in transport layer. So data link layer, this is the frame creation. Then comes it involves the movement of the data from one hop or one node to the next node. So like this is the structure you can see here. So you have uh, to send the data from A to F, let us say. Then the data that has come to the data link layer of A will be sent to its physical layer after putting the immediate next destination address, which is B. So the data travels, reaches B, physical and data link. Again, there a new source and destination address will be added. New source address is B, new destination address is E because it has to reach F. So again, the data moves hop to hop from B to E. At E, again, when it reaches the data link layer, a new set of address is added for source and destination, that is E as source and destination as F. So when it reaches F, that's the actual destination. So it will go to its above layers and finally reach the end user. The third layer from the bottom is the network layer. It is responsible for creating connections, routing the data. So in a network, in a complex network, there may be multiple parts to a particular destination. So the network layer actually helps you to route the packet. It follows a protocol called Internet Protocol, though it's not a very reliable protocol, but the above layers give you the required reliability. So other than that, it has few more protocols. One is Internet Control Message Protocol, ICMP, to relay helps the IP to report if there is any problem in the network. You can use this protocol to report the problem. Internet Group Message Protocol is used to relay some information to a group of nodes. Then Dynamic Host Configuration Protocol, DHCP. Um, if you know an IP address, you can detect the network. It helps you in that. Then you have a network layer. The role of the network layer is, see, this is what a network layer does. It takes the data from the transport layer, adds the source and the destination IP address, and passes it to data link. At the receiver, from data link layer, when the data comes, it will check the IP address. If it is for it, then only it will be sent to the transport layer. So network layer is responsible for the delivery of individual packets from source to destination. This figure will summarize that. Again, A is the source, F is the destination. So data that has come from transport layer to the network layer at A will be added with IP addresses and given to its data link layer. From there, it goes to physical. One hop, it goes to the B system where the IP address is different. Where it reaches the network B, but destination IP is different. So again, from B, it will hop to E. Then from E, it will hop to F. Okay. Next is transport layer. The role of the transport layer is it is the one that where true